Okay, um, polyatomic ions part 2. I'm going to assume now you know where to find your periodic table of ions. I did post it in Google Classroom, and so I'm going to show you my whiteboard now, whereas the first screencast only had the table of ions. So let's do a few examples of some balanced chemical formulas with cations and polyatomic anions. Here we go. I'm going to turn you here so you can see my board, and that should work. Let's give this a shot. Let's say sodium. The sodium ion is a 1 plus. It's Na plus. Let's say I wanted to get that together with the nitrate ion, which I talked about in the last video. The nitrate ion by itself is written as NO3 minus, -1 charge. Okay. If I want to get these two together, we're still thinking about balancing the charges and making them 0. Like I said in the last video, this 3 oxygens has nothing to do with the charge. You need to ask yourself, if this is a +1 and this is a -1, how many of each of these do we need? Excuse me. You simply need 1 sodium and you need 1 nitrate ion. So when we get them together, I'm going to write it. I'm going to erase this. And I'm simply going to write it. Don't forget the cation, the positive ion, always gets written first. I write it as NaNO3. No plus here, no minus here. The overall charge is 0. This is called sodium. We were to name it out in words, sodium nitrate. Now, pay close attention to this next one. I'm going to use the nitrate ion again, but I'm going to bond it with something that's doesn't match up well, something that doesn't have a +1 charge. I'm going to say the word while I'm erasing it, calcium. Look for calcium on your ion chart. You'll see that calcium is written as Ca2+. It's got a charge of +2 because it's going to lose 2 electrons. Well, that can still hook up with a nitrate ion. But this again has a charge of -1. -1 and +2 don't equal 0 when the 2 hook up. So you need to ask yourself how many of each. And here's the trick. This is why I'm showing you this particular example. You need more than one of these. You need 2 of them because this side is +2. This side has to be -2. What you do with a polyatomic ion, when you need more than one of them, you put the entire polyatomic ion in a parentheses, and then you add the correct subscript for however many you need. Reminder, we just said that we need 2 of these. So watch what I'm going to do. I'm going to bring this close. Actually, I'm going to go like this. I'm going to get calcium right there. That's going to be a 2+. I'm going to go like this. I'm going to take the nitrate ion, put it in parentheses, then I'm going to add a subscript 2. This is written as, or named as calcium nitrate. 1 calcium, 2 nitrates. Just a couple more and you should be able to see the pattern and get the hang of it. We're still balancing charges, we're just using polyatomic ions. How about sodium hydroxide, a very common chemical that hopefully we'll use if we ever get back to school. Sodium hydroxide, sodium's a +1, Na+. Hydroxide, if you find it on your polyatomic ion section, OH-. How many of each do we need? 1. We simply write it as NaOH. Cool. What if I wanted to use this again, but I wanted to use the magnesium ion? Once again, that's magnesium, Mg2+. Mg2+, OH-. How many of each would you need? You would need 1 of these, and you would need 2 of those to make this side -2. So we're going to write it as Mg parentheses, hopefully you can still see this, Mg parentheses OH2. Okay? Couple more. I'm trying to get progressively harder here. Check this one out. Your bone, uh, human bone, has a chemical in it called calcium phosphate. It's got the calcium ion, which is 2 plus, and it's got phosphate. Once again, phosphate. If you find it, it is PO4 with a charge of -3. It's written as PO4 3 minus. PO4 3 minus. 2 plus and 3 minus. They do not go into each other nicely. 2 doesn't go into 3 evenly. 3 doesn't go into 2 evenly. I want you to be thinking least common multiple. Is there a number that both of these charges could go into evenly? And the answer is 6. We need this left side, this cation side, to be 6 plus in total. We want this anion side to be 6 minus. Again, 6 plus, 6 minus. If each calcium is worth 2 plus, how many of them are we going to need? The answer is 3. So I'm going to write it as Ca subscript 3, but because this is a polyatomic ion, I need to put the whole thing in parentheses because I need more than one of them. I need 2. I need this to be a total of 6 minus. Calcium phosphate, your bone, is written Ca3 parentheses PO4 2. They don't get much harder than that. You're balancing charges, parentheses only if you need more than one polyatomic ion. You'll never see parentheses around an individual element that has a subscript. Last one, I'm going to include a transition metal. Let's do the copper 2 ion. Notice on your chart, there's either copper 1 that's possible or copper 2. This one is going to be copper 2, Cu2 plus. And I am going to use the hydroxide ion once again, OH minus. I'm using this one because we know that we're going to need more than one. We need one of these at 2 plus a piece. We need two of these at 1 minus a piece. This side's going to be 2 plus, this side's going to be 2 minus. When you get them together, it's written as Cu parentheses OH, then a subscript 2. But interestingly enough, the last part of this video, let's name it. Because you have an element that does not have a set charge, we can't just say copper hydroxide. We actually have to say, with that Roman numeral in the name, this is copper 2 hydroxide. Please don't hesitate to email me. I've been doing Google Hangouts with a few students. Let me know if you're struggling, and I'm here all day, happy to help you. Take care.